Alright, bonjour everyone, coming back on Miss G YouTube. So welcome to day 2 of the quadrilaterals chapter 5. So I'm not going to lie to you, today is going to be kind of lengthy on the notes. I know it's early release, so honestly, you'll probably just get through the notes and then that's it for today. Now remember, it says YouTube, you can pause, rewind, whatever you got to do. I know they also have closed caption on here, so if I talk too fast, you could always use that. Do what you got to do. Alright, but just make sure you are following and doing everything I do, especially the markings. The markings are going to be such a big deal today with everything that's going on. If you don't understand something I said, please rewind it. And remember, when I come back next week is the test. Next week is the chapter quiz. Chapter test. So please make sure you're doing what you got to do to understand this, and then be ready for any questions that I need to answer when I come back next week. Okay, so today we're going to dig a little deep now. We're going to actually go into quadrilaterals. So hopefully you remember quadrilaterals are four-sided figures. So no triangles today. So we have the front page, which is kind of focusing on mainly parallelograms. So all of these that you see here, parallelograms, rectangles, rhombi, squares, they're all technically parallelograms. But the bottom three are more specific types of parallelograms. Okay? Alright, so let's see what actually defines a parallelogram. And we're actually going to draw pictures in these spaces. So again, if you need to pause while I'm drawing this, just please do. Okay, so on a parallelogram, so parallelograms, they are like this. This is a basic parallelogram, and we're going to put all the different markings on them. Alright, so opposite sides are going to be parallel. Now keep in mind that for the symbol for parallels, we use arrows. So top and bottom, and then you're going to do double for the other side. Okay, to represent that these are parallel to each other and these are parallel to each other. Opposite sides are also congruent. So remember, for opposite sides are congruent, we're going to do tick marks. Like I said, it's going to get really filled in here, so just be careful with how you're marking it. Opposite angles are going to be congruent. So remember, angles are going to be curves. So you got 1, 1, opposite angles. And then here we're going to do 2, so that you don't think that all of them are congruent to each other. It's only opposites. Consecutive, which means next to. Consecutive angles are going to be supplementary. I hope you remember what that means. Supplementary is equals to 180. So in this case, a 1 curve plus a 2 curve is equal to 180 degrees every time when it comes to parallelograms. Alright, and last but not least, diagonals. So a diagonal is going to be that slanted line going from corner to corner. Diagonals are going to bisect each other. So remember, bisect means cut in half. So this will be the center here. So since we already used 1 and 2 tick marks, we're going to do 3 here. So that one is cut in half. But then on this one we got 1, 2, 3, 4. 1, 2, 3, 4. So this here is congruent to this side, and then this is congruent to this. Alright? So that is a parallelogram. Alright, so those are the rules that apply every single time, and you can use it in order to solve for a problem. Alright, let's move up to rectangles. Now, as you can see, rectangles have the same properties as parallelograms. So opposite sides are congruent, opposite sides are parallel, opposite angles are congruent. So let's go ahead and add to this. So it's all of that, but all 4 angles are right angles, which means 90 degrees, and diagonals are congruent. So let's go ahead and put this into an actual picture. Okay. So opposite sides are congruent, 1, 1, 2, 2. Then we have opposite sides are parallel, so let's put our arrows in there. Okay. Opposite angles are congruent. Now we know all angles here are going to be right angles, so let's go ahead and just put our little boxes. So technically opposite angles are congruent, and technically consecutive angles equal 180. They're supplementary. And then the diagonals bisect each other, which means they cut each other in half. But more specifically, the diagonals are congruent. So the number of tick marks are going to be the same all around. So 1, 2, 3, 1, 2, 3. And then same thing here. Since the diagonals are congruent, when they get cut in half, it's going to be the same for both diagonals. Okay? Alright. Let's continue here. Okay, so we have quite a bit more. Here we have run by have the same properties of parallelograms. Now a run by, I would ask you if I was there, if anyone knows, but it is like a tilted square. So it looks kind of like a parallelogram, but shorter because all the sides here are actually going to be congruent. But we'll get to that in a second. So opposite sides are congruent, but since all 4 sides are congruent, along with this, they're going to have the same number of tick marks. So we got 1, 1, 1, and 1. Okay, opposite sides are parallel still, so our arrows. Then we have opposite angles are congruent. Consecutive angles are still supplementary here. Diagonals bisect each other. Now we have some specific things going on with diagonals here. So let's go ahead and draw our diagonals. The first thing it says is diagonals are perpendicular. What does perpendicular mean? That they're going to make the 90-degree angle there, okay? So, diagonals are perpendicular, making a 90-degree angle there. And then diagonals actually bisect the opposite angles. So here, these angles are congruent to each other. The little ones, they get cut in half here. And same here, okay? Alright. So I put the tick marks for in here. We got 1, 2, and 1, 2, 3. Okay? Alright, a lot of information coming at you. Last but not least, we have squares. So a square has all the properties of parallelograms, rectangles, and rhombus. Okay, so all of this is true about it. Let's put it into a picture. So rhombus was tilted. A square is going to sit upright. So opposite sides are congruent, however, all sides are going to be congruent. So we got 1, 1, 1, 1. Opposite sides are parallel. This is still true, so we can use our arrows. Then we have opposite angles are congruent, but we know that all the angles are going to be right angles, which means that the consecutive angles still equal 180. Diagonals bisect each other. But just like a rectangle, the diagonals are congruent. So, there we go. And then just like a rhombus, the diagonals are perpendicular. Okay. So in all of these shapes, as you can see, we have triangles built inside. So keep that in mind when you're going to solve them. Alright, so that is it for the front page. I hope you got that. If you missed anything, please rewind. Go ahead and flip to the back. So these are a different version of quadrilaterals. Hang on 1 second. Alright, so you should have heard of these before in your lifetime. You got trapezoids. So, non-isosceles. Now, when you hear the word isosceles, you just automatically think back to the chapter we just had, where you had isosceles triangles. And when you had isosceles triangles, you had 2 sides the same, 2 angles the same. Okay, keep that in mind in a moment. So, a non-isosceles trapezoid, which is a basic trapezoid, has only 1 pair of opposite sides that are parallel. And that's already in the picture for us, those arrows. And then consecutive angles are supplementary for these as well. Now, the opposite angles are not congruent here, but consecutives are supplementary, okay, which means equals to 180. Alright, so in the picture, you would have that, but since the opposite angles are not congruent here, we need 3 and 4. However, the 1 plus the 2 curve is still congruent to, or equal to 180, I'm sorry, and the 3 plus the 4 curve is equal to 180. Alright, so let's continue. isosceles trapezoid. So an isosceles trapezoid have the same properties as a non-isosceles trapezoid, where only one pair of opposite sides are parallel, as you see here, and consecutive angles are supplementary. However, the non-parallel sides legs are going to be congruent. So these two are congruent. Diagonals are congruent. So basically this would have a tick mark, 2 tick marks, and this would have 2 tick marks. Base angles are congruent. So now in elementary or middle school, they're so used to getting you guys stuck to the fact that base means bottom. That is not always the case. So base can be these two. Yes, the bottom are congruent. But these are also considered base angles. Because imagine if you took this trapezoid and flipped it upside down, that would be the base. So base angles are congruent. And then opposite angles are going to be supplementary. So in other words, this one and this one, the 1 curve plus the 2 curve equals 180. 1 plus 2 equals 180. Okay? Alright. So this time it's not the consecutive, but the opposite angles. Consecutive are also 180 because it's the 1 and 2 curve. Okay. One more thing about mid-segment of a trapezoid. So the mid-segment trapezoid connects, the midpoints of the legs. So if EF, right here, is the mid-segment of trapezoid ABCD, then you would have half of AB plus DC equals EF. So if you add the top plus the bottom and cut it in half, you'll get the middle. Or, because most of you guys hate using fractions, you can say 2 times the middle equals top plus bottom. And yes, if you guys want, you could put the line above. I know you guys love doing that. Okay, to represent the segment. And that's it for the mid-segment of a trapezoid. Alright. Okay, last and not least for this part of the notes, properties of a kite. So a kite is a quadrilateral with the following properties. So you have exactly 2 pairs of consecutive congruent sides. So in this case, we got AB is congruent to AD, and BC is congruent to DC. So as you see these tick marks here. Then you're going to have 1 pair of opposite angles are congruent. So the only pair of opposite angles that are congruent here are going to be right here, B and D. So angle ABC is congruent to angle ADC. Alright, and then diagonals are perpendicular. So basically AC is perpendicular to BD. And if you can't see right there, there is a box. Now, something I do want you to recognize, if you ever get thrown on a test, future, now, worksheet, anything, an easy way to kind of remember what matches up here or what's congruent on a kite is kind of look at it like a body. Now, if I was in front of you in class, I'd kind of show you guys this, but let's see if I can do it here. So imagine this is your head. This is a person, happy. Here are your hands, and here are your feet. Okay? Now, here on your face, hopefully everything is symmetrical, right? So your 2 eyeballs are going to be congruent to each other. Okay? Now, over here, your hands are congruent to each other. However, your thumb is not congruent to your pinky. So you can't split top and bottom as congruent. However, B is congruent to D. And then on the bottom here, your feet are congruent to each other. So those 2 angles are congruent. So I know that sounds super weird, but it is kind of a way to remember what is congruent. Just kind of compare a kite to your body. And that'll be it for that worksheet. So at this moment, pause if you need to. I don't know if the sub is passing out both worksheets or one at a time for you. So if you need to, go ahead and grab the other worksheet, and then we will get started on the next. So, this is properties of quadrilaterals continued. So here we're actually going to use what we learned and solve some problems. So a lot of things are going to be going on now. I'm not going to constantly do all the markings because it puts a lot on a picture. But I suggest, just like I do, have your notes that you just did right next to you. Now, all these rules that I just threw at you, you will not have that on the test. You will have to memorize them. And if you can't memorize them, try to remember some kind of way. You know, make a song, whatever you got to do, so that you can actually learn how to use these properties. Okay? All right, so always read the directions. They are telling you something important. And in this case, it's telling you that for exercises 1 and 2, these are going to be parallelograms. Never, never, never. We do not assume in geometry. Okay? I'm not going to assume this is a rhombus or a parallelogram or whatever. I go with what they say, or I have to prove it. All right? So, we got here. Given is xy equals 15. Any information they give you, you better put it in the picture. So, xy is 15. Zx is 52. So again, like I said, there's going to be a lot in this picture. So try to follow me. Then we have angle wxt. So wxt, that means just this portion of the angle is going to be 35. And zwt. Zwt. So that one right here is going to be 59. Alright, so you have all your information in there. In case you can't see it, that is a 35 degree. Okay. Alright, so we're going to go ahead and solve for these. Now, the first thing it wants is ZW. Well, remember, opposite sides of a parallelogram are congruent, so I can go ahead and put 15 right there. Alright, the next thing they want is going to be TX. Now, I don't know if you were looking at your paper or not, but remember, our diagonals are bisected. So those are equal to each other. So if I know that from z to x is 52, I just do 52 divided by 2, and you will get 26. Alright? Angle TZY. So TZY. Well, this is a parallelogram, main word, parallel. So we have some parallel lines in here. Yes, you best believe it. You got some parallel line relationships coming back. So again, if you didn't look back at them last chapter, which I hope you would have, then you need to look back at them again now. Okay? So, remember you have parallel lines here. So we got some relationships. We have a 35 that was given to us. So by alternate interior angles, I can move a 35 right down there. So that is TZY. Then we have XYT. XYT I want here. Same thing again. We have another pair of parallel lines on this side. So look for relationships. Well, there's a 59 there. So best believe there's going to be a 59 here. Alright, I know there's a lot going on in that picture, but that's why you do one thing at a time. Don't try to attack the whole picture at once. Put the information they give you, and then answer one thing at a time. If you need to erase it as you go, do so. If you need to draw a bunch of parallelograms, then do it. Okay, whatever works for you. Alright. Number 2. It says if AC is 8x minus 14. So we got the diagonal is 8x minus 14. And EC, so that's just this portion of the diagonal, is 2x plus 11. Solve for x. So I don't have to plug anything back in, but we got to know our properties. And in the parallelogram, diagonals bisect each other, which means this side is congruent to this, and this side is congruent to that. So think about it. If 8x minus 14 is the whole AC, then can't I, and these are congruent, put 2x plus 11 right there? So now I have 2x plus 11 plus 2x plus 11 equals 8x minus 14. Now let's actually do some algebra here. So we got 4x plus 22 equals 8x minus 14. Subtract the 4x. We got 22 equals. Oh, my dog. Alright, sorry about that. I had to calm down the doggies. Okay, so we got 22 equals 4x minus 14. Add the 14 here. So we got 36 equals 4x. Divide by 4. X equals 9. Okay? Alright, so that is our answer there. So again, remember diagonals bisect each other, so these halves are congruent to each other, and these halves are congruent to each other. Okay? So remember, you can replicate things when they're congruent. Just write it again. Alright. Number 3 and 4 are rectangles. So keep that in mind. Look at your sheet that you have. We just did it. So it says DB is 42. AD is 26. Let's see, we got angle DAE. DAE, so we're going to go right here, is 42 degrees. And that's all they gave me. Round if necessary, keep that in mind. Okay, so let's go ahead and solve here. So they want AC. Well, if you go back, look at your notes about rectangles, you realize that you have diagonals are congruent to each other. So AC is congruent to DB. So if DB is 42, so is AC. Alright. Next, they want EB. Now, remember, based off parallelograms and rectangles, diagonals bisect each other. So, we know the whole line of DB is 42. So, from E to B, we just have to cut it in half. 42 divided by 2 is 21. My doggies are going through it today. Don't mind them. Alright, the measurement of angle ADC, we got ADC. Well, look at that. It's a whole corner. And we know the corners of rectangles are going to be 90 degrees. They're right angles. So that's given there. And then angle DEC. Well, that's a little bit tricky there, to be honest. Okay? That's what they want. Let me put double because it's different from the first one we have. That's what they want. Okay? So you gotta think here. Now the sides are parallel. And the only angle they gave me was the 42 up here, and I'm pretty sure it's for a reason. So, if I mark these parallel, I know alternate interior angles, so 42 can be moved right here. Alright, Miss G, well that's not exactly in the area I want, and look, there are triangles, so they will be useful here. Well, we know that the corners of a rectangle are 90 degrees, so 90 minus 42 is going to give us a lovely 48 degrees here. Make that an 8. Okay. Well, we got 48. We still got to work here. Now, keep in mind, I'm noticing there's a triangle here. Triangles total and angles is 180 degrees. So, if I can get at least one more angle here, we can figure out that double curve. Now, if you check your notes, we did it earlier, the diagonals are congruent. So if that has a 1 tick mark, then I can technically put 1 tick mark here. And if I block everything else, I now have an isosceles triangle. Isosceles triangle has two sides the same, means we have two angles the same. So remember I taught you the whole arrow trick. So if that's 48, that means this one is definitely 48. I know there's a lot going on, so just take a break. Now we still need to get that double curve. Right now I want DEC for the last answer. So let's go ahead and add those together. 48 plus 48, that's going to give you 96. Remember a triangle is 180. So 180 minus 96 is going to give us 84 degrees. And that goes right in there. Okay? So, you guys, if you've been slacking on some of these chapters, you need to look back. This is the biggest part about having the binder. You need to look back at your notes. If you don't remember that much from last chapter, to look back at it. Alright? So, always refresh your memory. It's all going to keep coming back. Okay. Number 4, we got VW. So that means this one right here is going to be 9x minus 11. And then SU is this whole thing is 16x minus 12. You're like, alright, Ms. G, well, they just gave us two different diagonals. And I'll be like, alright, well, look at your notes. Because you know that in a rectangle, all the diagonals are congruent. So that means this is congruent to this, is congruent to this, is congruent to that. So if I know that SU is 16x minus 12, and I know all the 1 tick marks is 9x minus 11, then I can just transfer this information over here, and I can make my problem. So 9x minus 11 plus 9x minus 11 equals 16x minus 12. And we got it set up to solve. Keep in mind, they didn't say x, so we got to find x and then plug it back in. So let's go ahead and do this. We got 18x minus 22 equals 16x minus 12. Subtract the 16x. You have 2x minus 22 equals negative 12. Add the 22. 2x equals 10. Divide by 2. X equals 5. I'm not done though. Plug it back in. So, WT. I don't have any information there. But, all of them have 1 tick mark, so they're all the same. So if I plug x into 9x minus 11, that will give me the answer to go there. So, WT, 9x minus 11, so 9 times 5 minus 11 gives you 45 minus 11, which gives you 34 for WT. And that is your answer. Okay? When you're ready, go ahead and flip the paper. So as you can see, there's no trapezoids on this sheet, so I'm going to be completely honest with you. Let me zoom out here real quick. Trapezoids are not going to be the biggest thing on this test. So we can talk about it, we learn about it, but the main focus I really want you to see and practice on is all your parallelograms. So rectangles run by squares and parallelograms themselves. Okay, so all we're doing today are just the basic quadrilaterals. Okay, so we have exercises 5 and 6 are going to be run by, so that's all we're looking at here for these two. So put in your information. ZY is 34. WY is 38. And the angle ZXY, so ZXY, so right up here, is 34 degrees. So the first question they asked me is WZ. What is that? Well, that's going to go ahead and be right here, so give me just 1 second. Alright, I'm back. So, we got 34 here, and we're looking for WZ. Well, remember, this is a run-by. All the sides of a run-by are congruent, kind of like a square, a tilted square. So if this is 34, so is this. Alright. Then we have ZV. Now, ZV is awkwardly in here. They did not say in our other notes that diagonals are congruent here. Diagonals, however, are bisected, so this is congruent to this. So if that is 38, I know that this side here is going to be 19. They also told us that the diagonals are perpendicular. So, I don't know if you're seeing it yet, but I have here a right triangle. And if I have two sides of a right triangle and I'm missing one, I can use the wonderful Pythagorean theorem to help us solve for it. But you need to be careful and make sure you set it up correctly. So, remember, it's a squared plus b squared equals c squared. Make sure you know you always label the c first because it is the hypotenuse across the 90. So this is your c. A and b are interchangeable. So, we have 19 squared plus b squared equals 34 squared. So for 19 squared, you would get 361 plus b squared equals, and then 34 squared is 1,156. Go ahead and subtract the 361. That's a little squished here, but you can keep going. So when you subtract the 361, we got b squared equals 795. And how do we get rid of a squared? square root. So square root that to cancel it out. B in decimals. It's going to give you a long decimal, and I forgot to write it. Round to the nearest tenth here. So it should come out to 28.2. There you go. Okay. And then the last one, we have angle WVZ. So WVZ, well, we just used a 90 degree here because diagonals are perpendicular. If this is 90 and they're creating a line together, well then, so is that side, 90 degrees. Cool. Excuse me. Alright, so done with that run by. Let's go ahead and, or run by, I should say. Go ahead to number 6. So we have measurement of angle HGI. So at the end of the day, they want HGI. They want this angle right here. Now we're like, okay, well, what do these have anything to do with that? Well, think about it. We have parallel lines here, right? So there's some relationships going on. So if I want here, the alternate interior would be right here. So if I can solve for x and plug right back into here, I've got my answer for what they want. Alright, so guess what? We're going to be looking at triangles again because they are so lovely and helpful. So I have a triangle here. However, we only have 2 angles, and we know it takes 3 angles to solve and set it equal to 180. So look at your notes. The diagonals of a quadrilateral are perpendicular. So it's 90 degrees right there. So we can go ahead and add all 3 angles together, set equal to 180. So we got 7x minus 1 plus 4x plus 3 plus 90 equals 180. From there, combine like terms, 11x plus 92 equals 180. Subtract the 92. We got 11x equals 88. Divide by 11. X equals 8. We got our x. We can go ahead and plug it back in. So remember, we said the best one to plug it into was here because it is the alternate interior to that angle there. So 4 times 8 plus 3 will give us 35 degrees. So measurement of angle HGI equals 35 degrees. Alright, I highly suggest if you are struggling here, there's a lot going on, look at this again when you go home. Alright, we have a little bit more and only a few more minutes left in class, so let's go ahead and get through this. 7 and 8, these are squares, so like everything is congruent to each other. We got some 90 degrees going on everywhere. So let's go ahead and do this. So number 7, we got AD is 11. It is a square. Keep in mind all sides are congruent. And then that's all they gave us, is round to the nearest tenth. So AC, they want me to solve for this giant piece right there. You're like, alright, Ms. G, but there's literally no information. There is, because all the sides are congruent. So there's an 11 there. And all the corners are 90. So again, I wonder if you see where I'm going with this, but you have a right triangle right there. So we can use the lovely geometry's best friend, as they call it, the Pythagorean theorem, to solve for the hypotenuse. So we got 11 squared plus 11 squared equals c squared. 121 plus 121 equals c squared. 242 equals c squared. Get c by itself. Just go ahead and do the square root. So c is approximately 15.6, since they want us to round to the nearest tenth. Alright, BC, they want to know, well, all sides are the same. So that's going to be 11. Measurement of angle DAB, so DAB, well, that's the corner. So you got a 90 degree angle there. And last but not least, angle CBD. So right here, well, remember squares have all the properties of all of them. And in rhombi, the corners are bisected, so they are in squares as well. So if the corner is 90 degrees, just divide it by 2, you got 45 degrees for that corner. Okay. Number 8, there's only 2 things here, and they want us to solve for VT. So they say that SW is 2x plus 13, and WU is 8x minus 41. Well, if you look at your notes, we know that diagonals are bisected, so this is congruent to this. Hence, 2x plus 13 equals 8x minus 41. Let's go ahead and do the math here. So we got to subtract 2x. 13 equals 6x minus 41. Add the 41. So we got 54 equals 6x. Divide by 6. X equals 9. Now, is that what they want? No. They do not just want x, they want VT. So they want this whole diagonal here. Now, remember, diagonals are congruent to each other. So if we plug it in for this line, it's going to be the exact same thing for this line. So we got 2 times 9, I'm just picking one, plus 13. Just pick either one because you're still going to get the same answer for both. So you got 18 plus 13, which equals 31. So if they're both 31, you got VT is equal to 62 because it's the same thing on the other side. Alright, so that's how it is when it comes to solving them. Yes, it seems like a lot. I know I just jam-packed a crap ton of information in there, but please make sure you look over this tonight. If you need to go over the video again, follow along with me again, whatever you need to do. But tomorrow you will be doing a lot of this on practice without me or videos. So, I mean, you can ask the sub to pull out the computer so you can look at the videos while you're going through the practice. That's perfectly fine. Alright, so one last thing I want to go over is a proof. Yes, proofs are going to come back, I promise, over and over again. I told you it's a huge part. So we got a proof. Charles wrote a proof based on the given information about quadrilaterals, A, B, C, D. Hold on, Mila. Alright, so it is given to me that AD is congruent to BC and that AB is congruent to DC. Select a statement for each box to complete Charles' proof. So at the end of the day, he wants to know that angle ADC is congruent to angle CBA. So what we have to do is kind of take these and put it in the correct order of how you can prove this is true. So let's just kind of read through these real quick. You got draw a diagonal AC through any 2 points. There exists only one line. Okay. So another one is AC and CA reflexive property. Well, there's no diagonal yet, so that might not be the first step. Angle ADC is congruent to angle CBA by corresponding parts. Congruent triangles are congruent. CP, CTC, we know we cannot use that until after we prove 2 triangles are congruent. So that's definitely not first. AD is congruent to BC. And AB is congruent to DC. Well, that's given, so we can definitely use that. And then ACD is triangle is congruent to triangle CAB by the side-side-side congruence. Well, we haven't even marked anything yet, like not fully. So the first thing honestly I would start off with is the given. So D, AD. Oh, I wrote AP. AD is congruent to BC, and AB is congruent to DC. So honestly, for the rest of them, I am not going to write all of it. I'm just going to write the letters. So, alright, so let's continue. And all of these will only be used once, so I'm going to go ahead and cross out as we go. So the next thing we have, okay, well, I see a bunch of things talking about triangles, so we should probably make triangles, right? So step A says to draw a diagonal AC. Alright, through any 2 points, there's exactly one given line. That is true, no matter what. So we can go ahead and draw that diagonal. Then, the next thing, well, we can't use that yet because that's at the end. We can't prove triangles congruent yet. So we can use the fact that, though, AC is congruent to CA by reflexive property. And I can mark it. Alright, now I can say that these 2 triangles are congruent by side, side, side. So there is E. And last but not least, we can finally say by corresponding parts of congruent triangles are congruent that angle ADC is congruent to angle CBA. So that'll be the end of that. Alright, so like I said, I know there's a lot that just went on. Please make sure you review your notes again. If you didn't get to finish this video in class, you need to make sure you finish it. At home, do what you got to do. It was a short day. And look over the stuff. Tomorrow you will get the practice and homework based off quadrilaterals. Alright? Well, have a wonderful day, and you'll hear from me soon. Bye-bye.